It says, yeah, it's recording. Yeah.
Oh, great.
Hello.
Hello, Miss. This
Hello.
Hold on just a minute.
Yeah, sorry. Hi, I joined in late. I was just caught on another call. Thanks, Sumesh, for starting, and I'm really sorry I about this.
No problem, Meenal. We just got started. I'm switching to a
Okay,
different network. I think my
we
bear
can't
with me
hear
for a
you.
minute.
Yeah, sure.
hello. Is anyone saying something?
No, we are all here, I think. No, Shiv,
Just
no one says anything.
switching Wi-Fi, so we're all just waiting.
Can anyone hear me now? Can everyone hear me now?
Yes, sir, we can
Yes,
hear
sir.
you.
Yes, sir.
Yes, sir, we can hear you.
Oh, okay, all right. Let's get started. So the wheelbase, we saw that we can make a very good wheelbase using 2 traction wheels and 2 omni wheels. That's the first option that we have for the wheelbase. The Rev Robotics kit also has a few more additional parts with which you can make a wheelbase
So
with
sorry to
four.
interrupt. Have you shared your screen?
Oh, my screen is not shared. Just a second. Okay, can you see my screen now?
So not yet. I just see your icon. Yeah, I can see it now.
Yes, sir.
Okay, all right. So like I was saying, the Rev Robotics kit also has additional parts with which you can create a slightly more complicated wheelbase. So let's look at the two wheelbase designs.
Is this speaking?
Hello, am I audible?
Yes, sir, we can hear you.
We couldn't hear you for a brief,
Okay.
like, brief few seconds.
Okay. So two traction plus two omni is your bot, and if you're looking at it from the top, then what you do is you have these two traction wheels in the front and two omni wheels in the back. Very simple design. We've already seen this. Here are the traction wheels, and the traction wheels are the ones that get connected to. So you would have a motor here that would connect to the traction wheels. So to begin with, this is the design that I would recommend all of you to start with. So this is the front where you have the traction wheels, and this is the rear of the robot. The next thing that you can do is you can make it slightly more complicated, and the Rev Robotics kit that you're all getting that will have the parts to help you make this. So there, what you do is you have two traction wheels in the front, like we saw last time,
Sir,
and we
I have a
also have
doubt.
another set. Yeah, tell me.
Sir, but isn't four mechanism wheels the best design? It provides the most flexibility and everything.
Vivon, mechanism wheels are very tough to program.
Yeah, they're very tough to code.
It's
See,
not good for
since
rookie
you
teams.
guys are just getting started into robotics, I wouldn't suggest that you get into mechanism. This is something that you can explore in your next season. For the first season, I would recommend that you start with something that is slightly simpler and focus on getting the maximum number of points rather than going for a complicated design. Because ultimately, what you need to do is to win. So if you pick up something like a mechanism wheelbase and start with it, then you would be spending a lot of time and energy in just building the wheelbase, and you wouldn't be able to focus so much on the other aspects of the. And ultimately, you wouldn't be getting so many points. So once you've gone through this first season and you slowly start mastering the concepts, then you can move on to a mechanism wheelbase. Maybe that's what I would suggest. So the way this particular wheelbase is arranged is you have two motors like I saw in the previous design. These two motors power the front wheels, and these traction wheels, they are not powered by any motor separately, but what is done is there is a sprocket here on the first motor, and there is a sprocket here on the traction wheel that is there in the center of the bot, and they're connected through a chain like this. Same on this side. There is a sprocket here. There's a sprocket here, and there's a chain. So this kind of a wheelbase is something that you can build using all the parts that you have in the kit.
So question,
Yes.
what advantages would building this wheelbase give, like over the other wheelbase?
Right. So the advantage that this wheelbase gives is oftentimes what happens is since there are rings lying on the floor, and it might happen that one of your wheels might get on top of lying on the floor, and one of your wheels might go over the wobble goal. In that situation, what happens is when one of the wheels goes over such an obstacle, then what happens is there are other parts of the robot that also get lifted up in the air. And ultimately what might happen is all your traction wheels, the ones that are powered by motors, they may all go up in the air. If that happens, then your bot will not be able to move. So it is better if you have more wheels that are powered than less wheels that are powered. So in the previous design, we saw that there are only two wheels that are powered, and in this particular design, there are four wheels that are powered. So if you look at this, so only these two traction wheels are powered, and if there is some obstacle because of which both these wheels go up in the air, then your bot cannot move at all. On the other hand, in this design where you have four wheels that are when one or two wheels go up in the air, you still there is a possibility that your other two wheels are touching on the ground or touching somewhere where you might get a grip and you might be able to move the bot. That's the advantage that you get out of here. Now in this ultimate goal game, this isn't much of an advantage because we don't have a lot of objects that would be lying on the floor. But if you have a game in which there are a lot of things lying on the ground, then this kind of a design definitely helps. So I'll give you an example. So 2 years ago, there was a game called Rover Ruckus. In Rover Ruckus, there was actually a moon crater that was made and it was kept on the ground. And the robot was supposed to crawl over that crater. And in such cases, then these additional wheels, they help a lot. But I agree in the ultimate goal game, it wouldn't give you that big of an advantage. So this is something that you should explore only when the rest of your bot has been already been explored and you still have some time and you're willing to do some changes, then you should explore this. But otherwise, I would recommend that you stick to the tried and tested foolproof design, which is the 2 traction plus 2 Omni. So this is about the wheelbase. So the wheelbase is pretty straightforward, nothing too complicated here. We'll now move on to the ring mechanisms and the wobble goal mechanism. So in the ring mechanism, we saw that there are 2 tasks we need to do. One is we need to pick up the ring and the other is we need to deliver the ring. So picking up is straightforward in the sense that there is only one option for you. It's on the ground and you need to pick up. In case of delivery, there are multiple options. For instance, you might want to go all the way to the low goal and simply drop it into the low goal. Or the other option is you might want to start shooting the rings. The advantage of shooting is you will be able to shoot from behind the line if you're able to make a good shooter. And there is a possibility of you getting more points. That is one advantage. The other advantage is you also have the other goal. What is that called? I'm forgetting the name. The one that you need to strike and push it behind you. Does anyone remember what is the name?
Power shot
Yeah,
target.
targets. Yes, power shot targets. So the other advantage of having a shooter is the shooter is the one that can push a power shot target. There is no other way for you to push the power shot target if you don't have a shooter. So there are these 2 options for the ring. So let's look at both of these options in a little bit of detail. So the ring mechanism, the first part is pickup. These rings are mostly lying on the ground and they would mostly be horizontal. In some cases, they may be at an angle. For example, there might be one ring that is partially rested on another ring and partially on the ground, so it may be on an angle. And in a very rare case, the ring may also be vertically up, but I doubt if that will be the case. I don't think the ring can stand vertically up. So picking up a ring would essentially mean you need to pick it up from the ground. So that is basically the mechanism that you need to design. So pick up from ground. Now the simplest mechanism that you can build in order to pick up from the ground is called a pick and place mechanism. So think of this as one finger and this as another finger, and you have a ring that is lying on the ground like this. And what you do is your robot has these 2 fingers mounted maybe on some kind of an arm, and that is fixed on top of the robot. And this arm has the ability to rotate about a certain axis. So if this is our bot, this is the arm mechanism, and imagine these are the wheels on the bot. So the simplest mechanism that you can build is build some kind of an arm like this. On one end of the arm, you have one or two fingers. You definitely need two at least. You might even want to have three. And these fingers would open and close. So these fingers would have this kind of a motion. They would open and close, and initially you'll start in the open position, and what you would do is you would come on top of the ring and place yourself on fingers. That would basically grip the ring between your fingers. So on one end of the arm are these fingers. On the other end of the arm, you have this pivot point on which your arm is mounted on the board. And this pivot point needs to have some kind of a motor over here, because ultimately we want to lift the ring up. So this motor will give you this kind of a motion of the arm. So essentially, this motor would be rotating in this direction, and about this pivot point. So this is the pivot point about which it will rotate, and that will give you this kind of a up and down movement to your arm. So
Sir,
in this,
I have a doubt.
yeah, tell me.
Sir, while moving our arm, there's also a chance that the ring may fall. So
Yes. So there is a chance that the ring may fall, which is why the design of your fingers becomes very important. So if you're building this kind of a mechanism, then you need to design your fingers in such a way that that doesn't happen. It's able to grip it should be able to grip very tightly onto the ring. Then it won't fall. So we'll look at various ways by which that can be done. So at a very superficial, at a very high level, this is how we can build a simple pick and place arm that can pick a ring up from the, and this same mechanism can be used to even drop it into the low goal. So if your strategy is that you will not be building a shooter and you'll be building only a mechanism that will drop in the low, then this mechanism is the only mechanism that you need. You don't need anything else. So about these fingers, since you have your ring, so if you look at it from the top, so your ring would look something like this, and your finger from the top may look something like this. So this is one finger, this is another finger. Now the easiest way for you to grip this particular ring is on this. So this finger would be made of some part from your Rev Robotics kit. So these are all aluminum parts mostly. So this would be an aluminum part and this would be an aluminum part. So what you need to do is you need to put some kind of a high friction material here, like maybe a piece of rubber over here and over here. So if you have this kind of a material on your fingers and you grip onto the ring tightly, then this material will provide enough friction for you to hold on to the ring. So this is one way of doing it, by using friction in order to hold on to the ring. Now, one thing you have to be careful is this particular ring is flexible. This is not a hard ring that we have in the game this year. So this is a flexible ring. So when you apply pressure on the ring in order to grip it, in order to get a hold on it, you need to be careful that you don't press it too much, because then the ring itself will collapse and ultimately it would fall off. So you need to be very careful about that. So this mechanism grips the ring from two sides. We could also build, sorry. So we could also build a mechanism. What happened to my whiteboard? Yeah. We could also build these fingers in order to grip it from more than two sides. So you have this ring, and what you can do is you can have three fingers instead of two. So again, remember, this is from the top. So these are your three fingers. So this will give you an even better grip, and you have less chance of the ring falling down. So you could build something like this as well. Now the advantage of this pick and place mechanism that we are seeing right now is there is also this task of dropping rings onto the wobble goal in the end game. So what the task what this mechanism would allow you to do is, so if this is the wobble goal, so this is the side view of the wobble goal, it looks something like this. This is the top view of the ring. This is the side or the front view. So you have this wobble goal, and ultimately you also want to be able to place rings into the wobble goal like this in the end game, because there are points for doing this. So the advantage of this mechanism that we saw is that the same mechanism can do both the jobs. It can even drop into the low goal as well as it can place it on the wobble goal. So one single mechanism doing multiple tasks is something that always is a good thing. So any questions until this point? Okay. So what we saw until now was how do you hold the ring using friction. So you will put a rubber pad over here and rubber pads over here, and they would hold it by friction. Another option that you have is instead of using friction, you can build a more predictive mechanism. So let me draw that. So you have a ring, and your finger can go below the ring. So what your finger would do is your finger would have two parts to it. One part will remain outside the ring and the other part can go below the ring. So if you look at it from the side, if the ring is lying on the ground like this, if this is the ring and your finger is coming from the side like this is your finger. So your finger could have an extension like this that can go below the ring and hold it from below. So if you have two fingers, the two fingers could be on either side like this, and you can have an extension at the bottom. Now this extension can be made of a very thin sheet of metal, something like 1 millimeter thick or maybe even less. So less than 1 millimeter. It'll be a thin sheet of metal that you can do, and when you grip onto this ring using this kind of a finger, then these thin sheets of metal will go below the ring, and you'll be able to grip it in a more predictive way. So once you grip it this way, you would have the thin sheet like this supporting it from the bottom. The ring will be supported from the bottom using this. And the ring would also be supported from the sides by these rubber pads that you'll have here. So you're supporting the ring from multiple sides, and this is a more reliable mechanism. So what you'll need to do is you'll need to build these different kinds of prototypes with 2 fingers, 3 fingers, and with this thin sheet at the bottom. And you'll need to do a lot of experimentation to figure out what is the best way to lift your ring. Another way to lift a ring is to lift it from the center. So this is your ring. So what you do is you insert your finger from the center like this. So you have these two fingers that you inserted from the center, and then you move these fingers in this direction. In this particular case, these fingers are moving in this direction because you're gripping the ring from the outside. In this mechanism, your fingers are inside, but you're moving them out. So you're gripping from this part of the finger and the ring. So this is another way of picking up the rings. The disadvantage of this is then you'll not be able to drop it onto the wobble goal, because this wobble goal requires the center of the ring to be free. But here the shaft of this wobble goal will interfere with the mechanism. So if you build this kind of a mechanism, then dropping on wobble goal will not be possible. So
Sir,
yeah.
So what's the
Tell
exact
me.
size?
So the ring is 5 inches in diameter. That is the outer diameter of the.
Sir, they have
Okay,
said
sir.
approximately 5 inches, like about 5 inches, not exact
Yes, it's
five
approximately
inches.
5. Yes, and this thickness is I think 3/4 of an inch.
Thank you, sir.
So there are these various ways by which you can pick up a ring. If you have a pick and place kind of a mechanism. Now, like I explained, the pick and place mechanisms are the easiest to build. They require the least number of parts, and these are multi-purpose. So this mechanism can be used to pick up the ring. The same mechanism can be used to deliver the ring into the low goal, and the same mechanism can be used to push a ring on the bubble goal. So this can actually do 3 tasks. So this kind of a mechanism. So when you begin your prototyping, this is the first mechanism that you should build and try out, because once you try this out, then you'll get to know a lot about how you go about picking up these rings. And if you want to build more complex mechanisms, then building this first will give you a lot of ideas on how to make it more effective and more complex. So this is something that you should definitely try out first. Now in design, whenever we talk about design, there is one principle that we always follow. So that principle is called keep it simple, stupid. In short, this is also called the KISS principle. So what this means is build a very simple design. Don't try to make the design complicated. And the reason why we should not make a complicated design is because if it takes, say, X amount of effort to make a simple design, then it will take something like an 10x kind of an effort to make a mildly complicated design. And it will take 100x effort to build a reasonably complicated design. Now, this might not seem very intuitive. Why does it take X, 10x, and 100x? 100x meaning it will take 100 times the effort to build a complicated design than it takes to make a simple design. Now, the reason is because when you make a design, you're making a mechanism that actually does something physically. It is not something that you're drawing on paper. It's not something that you're making in CAD, or it's not something that you're making in the form of a program that is very precise. Whenever you make a physical design, whenever you make an arm or you make a wheelbase, there are so many variables over there. For example, one of you pointed out that the ring may fall. Now, if you make a complicated design, then the possibilities of your ring falling may be more than what you have in a simple design. So ultimately, your goal, what is your goal? So your goal should not be to make a complicated design. Many teams don't get this. So this should not be your goal. Many teams think that if you make a complicated design, you can make a better bot and you can win. That's not the case. So to give an example, one of you talked about using a mecanum wheelbase. A mecanum wheelbase is a complicated design. It's not going to win you matches unless you are already an expert team and you know a lot about it. Your goal is to win matches. And to win matches, you need more points. More points are the only way by which you can win matches. Making a complicated design, more points are the only way by which you can win matches. So your design should always be tuned towards getting more points. Sorry, I meant more points. So your design should always be tuned towards getting more points so they can win more matches. And a simple design is the best way to go about it, because the simple reason for that is there are so many mechanisms you need to build. You need to program for the autonomous mode. You need to program for the driver control mode. You need to program for the end game. You need to build all these mechanisms for each of these games, and there is plenty of work. If you start with a complicated design, I can guarantee you'll not be able to finish even half of that work. So the best way to do it is to start with a simple design, make sure everything is working and you're getting points. And the next thing that you should do is, how can I get more points? I have a simple design that is doing everything I want it to do. It's able to pick up the rings, it's able to drop the rings, it's able to pick up the wobble goal, it's able to place the wobble goal, it's able to maybe shoot as well, it's able to push the power shot target. I have a simple design and it's able to do all of this. That should be my goal. That should be my first. Once I have all of this ready, once all of this is working well, then what you should do is, now how can I get more points than what I'm getting now? So for example, I may not build a shooter in my first simple design, because shooters are not simple designs. Shooters are quite complex. I might simply build a pick and place arm that can simply go and drop in the low goal. I know that I'm not putting those rings in the mid goal and in the high goal, or even shooting the power shot targets, but still I'm getting some points. And once I'm done with this, once the team has made the bot that is doing all this, then the next thing the team should do is, okay, now let me think about a shooter. Now I already have, say, 100 points that I'm winning in every match. I'm earning 100 points in every match. Now I want to take that 100 points to maybe 110 or 120. And what do I do in order to make that happen? And then you might decide, okay, now I want to have a shooter. Then you build a shooter and you attach a shooter to your bot, and then you start earning those next 10 points or 15 points or 20 points. But remember, just like we have this KISS principle, there is also this other principle. And what this says is 80% of points, they come from 20% of effort. So what this means is, whatever effort you put initially, that effort will get you 80% of the points with just 20% of that effort. Now to get the remaining 20% of points, you need to actually put 80% effort. So when you start building your bot, this should be your goal to do first, because ultimately putting in effort is not something that is going to win matches for you. Getting more points is going to win matches for you. So initially what you should do is, you should take a simple design and target maximum points. And from that perspective, having a simple mechanism like a pick and place arm is a very good way to get started. I'm not saying that you should restrict yourself to this mechanism, but definitely start with this mechanism, have everything ready, have your autonomous programmed, have your wobble goal mechanism ready, have the mechanism to pick and place your rings ready. When everything is done and your bot is now, say, getting you 80 or 90 points, then you need to start moving on to a more complicated design. So let's discuss a slightly more complicated design if you want to do rings.
So the finger mechanism is good, Sachin.
Sorry, could you repeat that question? Sorry, could you repeat the question? I couldn't hear it properly.
So should we go for the finger mechanism?
Yes, as your first prototype, you should build your finger mechanism, and depending on how much success you have with it, and depending on how much of the rest of the work you've completed in the amount of time that you have before the competition, you can either make that your final mechanism, or you can move on to a more complicated mechanism. But definitely don't start with a more complicated mechanism, because I can guarantee you that you'll not be able to finish it in time, and you won't be able to get even those points that you could have got with a finger mechanism. I'll give a very good example, a practical example about this. So in the last year's FTC challenge, so the game was Skystone. And in Skystone, if you remember, I had shown you those yellow colored blocks that had to be picked up and they had to be stacked in a particular location. Now, a lot of teams, what they'd done is they had built quite complicated mechanisms of picking up those blocks. So many of the teams, what they did was they made some kind of rollers using wheels where those rollers used to suck in those blocks into the bot, and then they had a separate mechanism to lift that particular yellow block onto a height and stack it over there. Now, there was this one team last year. That team consisted of only blind students. You won't believe it. There was a team in FTC last year. All the students were completely blind. There were 2 or 3 of them who had partial vision. They could see maybe 10% or 15%. They didn't have vision beyond that. And the rest were all completely blind. And since they were blind students and they were rookie teams, this was their first time doing robotics. They started with a very simple mechanism in order to pick up these blocks. And they used a mechanism similar to what I just described. It was a very simple arm, and the simple arm moved very slowly and picked up those blocks, and the bot moved very slowly and placed the block onto the location where it was supposed to be placed. Now, when they started this game, there were 47 teams last year who participated in FTC. So when they started, when they played their first match, nobody thought, that they could proceed a lot, because first of all, they were blind, they could not see at all. The drivers could partially see. There were two people who could see 10%, and they were the drivers. They were having a really hard time seeing what is there on the field, but still somehow they could manage seeing a little bit. And nobody thought that they will be able to make a lot of progress because the mechanism was extremely simple. You won't believe it. They reached the finals, and overall, in terms of the number of points that they got, they were ranked number 8th in FTC out of 47 teams. And the teams that built a lot of complicated mechanisms, they were not able to even reach the finals. And these guys were way ahead of them. The only thing that they did was they built a very simple mechanism, but they practiced on that mechanism a lot. They spent almost 1 month before the competition practicing that mechanism. They moved very slowly. They didn't have a lot of speed because for them moving at a speed meant you need to be able to see properly, but they couldn't see properly. So they moved very slowly, but they were very reliable. The mechanism was simple. It worked 100% of the time. And they practiced so much on it that they never missed an opportunity to score a point. And they didn't target all the tasks that needed to be done. They did not target that because they knew that many of those tasks are complicated and it will take away all their energy and they will not be able to perform in the. And this team, they stood number 8 out of 47 teams, and that was a big surprise to everyone. So that is an example that I always give. Start with a very simple design, focus on finishing your complete bot, have your autonomous programming ready, have your all other programming ready, play a match on the play field and play multiple matches. Try to see what kind of a score you're getting. And once you are getting a particular score, then see how you can improve. That is how you should be building your bot. So moving on to a slightly more complicated mechanism for picking up rings. So this mechanism is now divided into 2 parts. It has a separate pickup mechanism and a separate delivery mechanism instead of a same mechanism for doing both the tasks. The advantage that this has is for delivery, you can use a shooter. And if you have a shooter, then the shooter can go to your high goal. It can go to your mid goal. And it can also go to your power shot target. But as you can guess, the shooter is quite complicated. So this is something that you should try once your basic bot is ready. And for picking up, we have a couple of options. One is we could use the same arm that we saw. So we build an arm to pick up the ring. And what the arm would do is it would first pick up the ring and then it will place the ring on the bot itself. And then your delivery mechanism will pick up from bot wherever your pickup mechanism has dropped, and then the delivery mechanism would shoot. So your tasks are broken down into 2 mechanisms. One is the pickup pickup mechanism, the other is a delivery mechanism. So the sequence in which it happens is this is so if this is your bot like this, then on one side of your bot you have your pickup mechanism that will ultimately pick up the rings. On the opposite side of your bot is your delivery. This delivery could be a shooter or it could be something else. Shooters give you good range, so a shooter is something that is definitely something that you can try once you reach this particular stage. And then in between these two, there has to be some kind of a conveyor mechanism. So what will happen is you will have your ring. This is your ring that will get picked up by the pickup mechanism. It will enter the pickup mechanism. This pickup mechanism will push this ring onto the conveyor. So this is your ring. The conveyor will transport this ring all the way to your shooter. It will come and it will stop in the shooter. At this point, it is ready for shooting. And then once you trigger your shooter, this shooter will shoot it out. So this mechanism that we saw in the first design, that was one mechanism. Now this is actually replaced by 3 mechanisms. So your design has become 3 times more complicated just by the number of mechanisms. And if you look at the shooter will probably make it 10 times more complicated because the shooter is not always accurate. So you're actually making things 3 into 10 times, that is 30 times more complicated in terms of the effort that you will have to put into making this mechanism. So definitely this mechanism, if you're able to put in this kind of effort and you're able to make it perfect and you're able to get good accuracy, it will give you more points. But remember that this will probably take 30 times more effort than what it took for you to build the simple arm. So once you're done building the simple arm, once you know how many points you're getting with it and you have time, then you can definitely attempt this. You can try this out. Now, one disadvantage of this kind of a mechanism is it makes your bot heavy because you're replacing one mechanism by 3 mechanisms. And if your bot becomes heavy, then there are many issues that come with the bot. It becomes sluggish.
Sir, I have
You
a
need
doubt.
more powerful motors. Hold on, I'll get your doubt. You need more powerful motors. And the other thing you'll need to do is you'll need more motors because motors are the only way by which you can make anything move. Yeah, sorry, what was your doubt?
Sir, so I was asking that in FTC, is there a weight limit?
Yes, there is a weight limit. If you read the game manual part 1, you will come to know that there is a weight limit. I think it's 45 pounds or something like that, which is approximately equal to 20 kgs. So like I was saying, having these 3 mechanisms will make your bot heavy. It will make it more sluggish. Your motors will have to be more powerful and you will need more motors because if your pickup mechanism required 1 motor, you'll need 1 more motor for your conveyor mechanism. And you'll at the very least need one motor for your shooter, for your delivery mechanism. So you'll need 3 motors here. Now you might not want to use DC motors in all the 3 places. So remember, in the FTC kit that you have only 2 core hex. You have only 2 core HD motors, and you have 2 core hex motors. So these are the 4 DC motors that you have. And in addition to this, you have 4 servos. These are the motors that you need to use to build your entire bot. Now these 2 core HT motors, they are gone in your wheelbase. Your wheelbase needs 2 core HT motors. Now what you have remaining are 2 core hex motors and 4 servos. So your mechanisms that you build for doing all your tasks will have to use these motors. So for example, for a conveyor, you might get away by using a servo here instead of a DC motor, because this conveyor is only delivering your ring. The ring is pretty lightweight and it doesn't probably require a lot of power. But your shooter will definitely require a core hex motor, because a shooter will require a lot of power because it has to shoot a large distance. Your pickup mechanism, depending on how you design your mechanism, you might require a core hex motor for this, or if you design it intelligently, you might get away by using a servo as well here. But again, the moment you use a servo is a low powered motor. There will be a lot of restrictions if you use a servo in your pickup mechanism. Now, if you look at the number of motors that you have available, all your motors probably will get consumed in this particular mechanism itself, except for maybe a couple of servos will remain. Now, remember, besides this ring mechanism, you also need to build your wobble goal mechanism. You need to pick up your wobble goal and drop it into the target zone. And in the end game, you need to drop it back to the starting line. So you need to keep some motors for that as well. Now, there are two ways to get around this problem. One is try to use servos wherever possible and use your DC motors very sparingly and use them only wherever they're required and not everywhere else. The other is go with a very simple design, the one that we saw where it was using a single arm that was doing all of this, as well as it was dropping rings on the wobble goal as well. It was able to push the rings on top of the wobble goal as well. So go with that kind of a mechanism that uses fewer motors. The other option that you have is to buy more additional parts besides what is coming in your kit, and you'll need to buy several such parts because it's not just motors. You'll need to definitely buy more motors. You'll need to buy maybe some core HD motors and core hex motors. Along with that, you'll also need to buy the rev expansion hub, because the hub that comes with the kit, it supports only 4 DC motors, and those 4 DC motors are these DC motors. Besides this, it will not be able to support any more motors. If you want to use more motors in your design, you'll need to buy one additional expansion hub and you'll need to buy those additional motors. Now, that is a decision that you guys can take as a team, whether you want to do that or you want to focus on building a mechanism with whatever parts are there in the kit. Now, remember, the more complex mechanisms you build, the more time it will take for you to do it. And if you are not able to do it in time, by the end of the season, you will not be able to have a bot that will get you the points that it should have got. Any questions until this point? Yeah, did someone have a question?
Yes, so how are we going to build these bots?
Yes, we'll look at each of these individual mechanisms. So let's begin by the yeah, what is your question?
So how are we going to exactly build these? Like, we can't exactly meet and actually do all this.
Yes, that is a big challenge. So this is something that Milan ma'am and we were discussing. We have discussed this many times in the past. What teams typically do is they divide the entire team into smaller teams, and each smaller team takes on different responsibilities. For example, if you have, say, 9 people or 10 people in your team, you could break it down into 3 sub teams. A team of 3 students can form the hardware team that focuses completely on building the bot. Another team of 3 people could 3 students could
So I think I'm mute.
collecting all the content that you need to include in an engineering notebook, writing the actual engineering notebook, and so on. So what you would need to do is you need to divide your team into such small teams, and then each team will need to figure out how they can collaborate with. For example, the programming team and the outreach team, they can collaborate remotely. You can all be at your homes and just work on your laptops and still be able to collaborate. But the hardware team, the team that needs to build the bot, they will need to get together in person. There is no way around that. That will need to be figured out. So I will leave it to Meenal ma'am to figure out all these logistics. But that is something that will need to happen. A few of you, the ones who are interested in building the bot, you will need to get together. Maybe at somebody's home, or if your school allows it, then in the school, maybe something like that. Okay, so let's look at what all mechanisms. So we saw that there are three mechanisms in this particular design. We have the pickup mechanism, we have the conveyor, and we have the shooter. So let's start with the pickup mechanism. One of the pickup mechanism that we saw was the pick and place arm. This we've already seen. Sorry, pick and place. Another thing that you could do is you could use rollers to pull in your rings. Let me draw this. So this is your bot. These are the rear wheels. I'm not drawing the front wheels because they would be interfering in the mechanism. So just for the sake of drawing, I'm just drawing this here. So what you'll have is you'll have a roller like this. Now this is a side view of your bot. This roller would come in contact with the ring which is on the ground. This is the ring lying on the ground. This roller is rotating in this direction, and the bot is moving forward in this direction. So as the bot moves, pull in your rings. So you could have a roller which is rotating like this, and when your bot moves forward like this, your ring is on the ground and there is friction between the ring and the ground, so the ring won't move on the ground. And what your rollers would do is these rollers would pull in these rings inside the bot, inside the body of the bot. And when they come here, then you need some kind of a ramp here. A ramp is an inclined plane in your bot. So what would happen is this ring, once it is pulled in by the rollers, it would climb up the ramp like this. So the ring would come something like this. So now your ring has been picked up from the ground and it is now inside the bot. So this is one thing that you could do. Then the second part is, so your shooter would be mounted somewhere here on the back of the bot. This is the shooter. Now you need some kind of a conveyor mechanism to convey this ring from your pickup mechanism to the shooter. And to do that, what you can do is the simplest thing you can do is you can come up with some kind of a conveyor belt. So conveyor belt is very similar to the luggage belts that you see in airports. So after your plane is and you go and wait in front of the belt, and so that is called a conveyor belt. So you'll need to build some kind of a belt here. So that belt will look something like this. It will have two rollers like this. And there would be a belt that would go over the roller. And your ring would move on this. Like this. In this direction. So this ring that you see here, this ring is this ring. This will start moving up, and at the other end of the conveyor, you'll have your shooter mechanism. So the conveyor belt, what it will do is it will take the ring from your pickup mechanism and it will insert it in an appropriate location. So the ring has to be inserted in the correct place in your shooter mechanism. Otherwise, your shooter will not be able to shoot it properly. So it will bring the ring and it will insert it over here. And once it has been inserted, then the shooter mechanism can start shooting. So you'll need to build some kind of a conveyor in order to make this happen. So you have a roller here that will do the intake of the ring, that will pull in the ring. You'll have a conveyor that will move the ring all the way up to the shooter, and then finally you'll have a shooter mechanism. So let's look at how a shooter can be built. Now there are a couple of ways by which you can have a shooter. I'll talk about a few simple shooting designs. So if you're looking from the top, your ring, once it is inside the shooter mechanism, will look something like this. So this is your top view. And this is the direction in which you want to shoot. This is your shooting direction. And your ring has come from this direction. The conveyor has pushed it here and it has brought it into this position. Now, simple way to make a shooter is called a flick shooter. So basically, what a flick shooter does is you have a flexible a piece, something like this, made of a flexible material. And what you do is you pull this in this direction. So this part of the flexible material is clamped. This won't move. I'll mark it by green. So this part is clamped onto the bottom of the robot, and using some mechanism, you pull it in this particular direction. So this direction. So this is the front view. This is the side view of your bot. So basically, what you do is you pull it down like this, and the shape that this will take will be something like this. It will become like this. And it will continue to be remaining. It will continue to remain attached to the body of the bot. And once it comes in this position, then your ring will come and it will get delivered over here. Or to put it better, your ring will come and get delivered somewhere here. Remember, this is the side view. This is the top view. And this could have some more parts to it. So what you do is, for this flick shooter, this is called a flick shooter because the action is just like you're flicking an object. So the moment you release, so as long as you're holding this particular flexible piece in position, nothing will happen. But the moment you release this will immediately become straight like this. And in this process, it will flip the ring in this direction. So this is a flick shooter that you can build.
Sir, I have a doubt.
Yeah.
So over here, sir, accuracy will play a big role, right? So because I don't think this method will be that accurate.
See, it depends on how you build it. Theoretically, you cannot say which will be more accurate, which will be less accurate. It depends on how you. For example, if you want to improve the accuracy of this mechanism, what you can do is you can make some kind of a slot here so that the ring always moves only within that slot.
Yes, sir.
And when you have something like this, then your ring will always go out in a very determined direction. So the direction will always be this. It will not go like this or it will not go like this. So like this, it will depend on how you're building it. And then there are many ways by which you can guide the. You can have some kind of a slot using which you can guide a ring to go in a particular direction. So the reason I brought in this flick shooter is because it's very simple to build and it's very simple to understand. This is definitely not the best mechanism. There are other better mechanisms out there. So another mechanism that you can use that is similar to the bowling machine mechanism. So if you've been to, if you've seen a bowling machine at any point of time, then those bowling machines, what they do is they have two rollers. They have a roller like this and they have a roller like this. And if it is a cricket bowling machine, then this would be a cricket ball, and this cricket ball would come, and these rollers, they are rotating at a very high speed. For example, this roller would be rotating in this direction, and this roller would be rotating in this direction, and your cricket ball would be pushed in from this direction. Now the distance between the rollers, so this distance would be slightly less than the diameter of the ball. So suppose your ball diameter is say 100 mm. What you would do is you would make this 95 mm as this distance, the distance between the two rollers. And these rollers are made of flexible rubber. And this cricket ball is a hard ball. And these two are made of flexible rubber. So what happens in this case is the moment this ball is inserted into this gap, these rollers, they push this ball out at a very high speed in this direction. So this is how these bowling machines work. Now, one way of building a shooter is to use this mechanism or something very similar to this. So let's look at how this can be used. So again, we can have two rollers. This is one roller. This is another roller. In our case, we'll have a ring in between. So this red is our ring. Now, one thing to note is this ring is flexible. And when ring is flexible, then you need to have hard rollers. Then you cannot have rubber rollers. They need to be hard rollers. Because ultimately you need to be able to grip onto the ring and shoot it at a very high velocity. Now, if you look at this mechanism, this is very easy to build. All you need to do is you need to put one motor here, you need to put one motor here, and just run the motors in these directions, and your mechanism is more or less ready. As soon as this ring comes in between, it will immediately shoot out in this direction. Now remember, there are two rollers here, so this design will require two motors. We can actually get away with one motor. So let's look at how we can get away with one motor. So in case of one motor, what you need to do is you have this roller, one roller with one motor on it, and you have our red ring. And on the other side, instead of having another roller, what you would do is you would have some kind of an aluminum channel like this, and this is fixed to the bot. This is fixed to the bot. So what will happen is your roller is rotating in this direction. Your ring comes in this direction, and the moment the ring comes in this position, this roller will make sure that it pushes it out at a very high velocity. So it will push it out in this direction. Now remember, in the previous mechanism we saw, that the ring was pushed out in this direction. In this mechanism, the ring is getting pushed out in a slightly different direction. So the advantage of this is you only need one motor. The disadvantage of this is direction is not straight. But this can be easily compensated by mounting your mechanism in such that this becomes the front of your robot. So your robot will get this mechanism can get mounted somewhere like this. If you do it this way, then again your ring is coming out straight from the front of the robot. All you've done is you've rotated your entire mechanism in order to compensate for the angle at which the ring is getting shot out. Another advantage of this Another advantage of this is this gives spin to the ring. Can anyone tell me why is spin an advantage?
Because the height is to get to the third ring on the, I mean, to get to the highest tier. Or
So you need that much speed, so.
So spin doesn't give you additional speed.
Door.
No, spin gives you constant direction. So if you, so for example, if you have ever played with a frisbee, try throwing a frisbee without spinning it, and then throw it with a spin. Do you see a difference? Have you ever tried that out? There's a big difference. If you spin it, it goes along a particular direction in a very predictable way. But if you don't spin it, then it starts wobbling and it just flies as if it's some random object. But if you give it a spin, the axis of rotation of the spin makes sure that the frisbee is always upright. It doesn't wobble at all. So giving a spin to the ring will make sure that the spring is not wobbling when it is flying in the air. And if it is not wobbling, then it will go along a straight line or along a predictable parabolic path. It will go along one of those paths. But if you don't have a spin, then it's very likely that your ring will start wobbling. And if once it starts wobbling, then it's not very predictable where the ring will go. And it is shooting out at a very high speed. If it starts wobbling, then because of the resistance of the air, your direction can keep changing. And that is something that you don't want if you want your mechanism to be repeatable and if you want it to be consistent.
So I have a question.
Yeah, tell me.
Are we allowed to, for example, okay, if we do this mechanism, sometimes it's easier to know for example, this is when the non-automated period, when the user control period is going on. So is there a way, are we allowed to, for example, mount a laser pointer so that, like it tells them where exactly they're aiming? Because as you said, I heard you earlier speaking about where the drivers exactly couldn't see much of the field. So in this case, are we allowed to mount something like that so that you know at least where or what angle your shooter is pointing at?
So you're not allowed to mount a laser pointer because laser pointers are not included in the list of legal parts. But you can mount LEDs on top of your bot, and you can light them up using the control hub. Now that LED is of use. Yeah, that won't help a lot. I know that won't help. But if you can put a lens in front of an LED, it might, But yes, the laser pointer is definitely not allowed.
Okay, thank you.
So one thing that you can do is you can make use of vision. So there is a camera that comes with the kit, and you can make use of vision to actually solve this problem. So you can turn on your camera and using the field of view of your camera, you can probably adjust the angle of your bot so that you're able to shoot accurately. So you can use vision for that purpose. That is allowed. So this is.
Thank you, sir.
So I'm not sure if it's just me, but but your voice is breaking off halfway through.
Off again?
Yeah, so I just heard you say off.
Okay. So give me a minute. I'll switch my network again.
So I can hear you fine.
Can everyone hear me? I'm audible.
Yes, sir. Audible.
Yes, sir, you're audible.
Okay, am I audible? Can you hear me?
Yes.
Yes, sir.
Yes, sir, somewhat.
Yes, sir.
Hopefully it will be better now. And my screen is also visible, right?
Yes, sir.
Yes. So another way to build a shooter is to use a catapult. So if you have played with a catapult when you were kids, you would know what I'm talking about. So catapult typically looks like this, the ones that we all play with. So it's a Y shape, and then there is a elastic band like this. And what you do is you place the object that you want to shoot somewhere here. You pull this elastic band in this direction and you release it, and your object then shoots out in this direction. So you could use a catapult kind of a mechanism on your bot as well. How do you do it using the robot kit? Let's quickly take a look at it. So what you can do is, this is the top view. So this is your bot, and what you can do is you can have two posts to which your elastic band is attached. And this elastic band is connected to a tray. So this elastic band is connected to a tray, and this tray is on a rail that allows it to move only in, so this particular tray can move only in this direction, back and forth, because it has this rail to guide it. So that's how the tray is there. And what you do is your ring, it gets placed on top of this tray by your conveyor mechanism. And then what you do is you pull your, so your initial starting position of the tray may be somewhere like the ring. So this is before the ring got placed. Sorry, this is the starting position of the tray. Then you would have a motor that would pull the tray and bring it all the way up to here. Then your ring gets placed. This ring gets placed on the tray, and then you have another mechanism to suddenly release this tray, and then it shoots out this ring in this direction. So a catapult kind of a design is also something that you can consider. So these are some of the options that you have for your shooter. Now, in terms of making it, in terms of keeping it simple, you'll have to try out all these prototypes and see what kind of accuracy you're getting, because you need both the things. You need speed because your bot will be around 5 to 6 feet away from your target, and you need accuracy as well. And when you talk about accuracy, it should be repeatable. If you shoot 10 times, then each of those times it should go and hit the same target at the same position. So it should be accurate, it should be repeatable, and it should be fast. So these are the three things that you need in a good shooter. And believe me, making a good shooter will take you several months. Several months, especially to get the repeatable and the accuracy part of it.
So please can you
Yes.
explain me in short is what happened in this method? I didn't understand.
Sorry, could you repeat your question?
So please can you explain me again this method in short, like what happens? I couldn't understand nor see your screen.
You mean the catapult?
Yes, sir. Please can you explain it again in short?
Okay, all right. So in a catapult, essentially what you do is This is a tray. Tray is on a rail. This is the rail of the tray. This rail allows the tray to move only in this direction. So to begin with, your tray would be somewhere here. And this elastic band would be connected to the tray like this to begin. Then what you do is you build some kind of a mechanism to pull this tray in this direction so that it comes and it rests. When it does, then your elastic bands come here, and now these elastic bands, they have a lot of tension in them. It's like just like you're pulling a catapult. Remember, this is the top view. Top of this tray. Then you have a mechanism to release this tray at this position, and because of this elastic bands, it will start to move in this direction at a just like a catapult. And because of this, this ring will shoot out in this direction. Is that clear now? Okay, so these are some of the ways by which you can build a shooter. Now we are at 1 o'clock. So Meenal, do we continue or do we break?
We can break here. I think this is a logical place to break. So does anybody have any questions?
Yes, miss.
Sir, please can I stay back and speak to you about like our thing, our design?
So even he wants to speak to you
Sure.
about our mechanism.
Sure, we can do that.
Anybody
So
else wants to have to talk?
Miss, I have a question for you.
Yeah.
Miss, when will the skill building for the robot programming take place?
We will discuss all the AS issues later. It'll happen subsequently after this whole thing is over. Any question on today's class?
Yes. So can I stay back and speak
Yes,
to
you
the-
can. You can.
Wait, miss, and other teams finalized those 4 different teams of 11 people for dials?
You guys have been asked to do it on the group. Now, are you a part of the group?
Yes, miss, but are those teams finalized?
Yeah.
Yeah.
Yeah. So whatever you'll have put in, just put the final things again now on the group, and then I'll just kind of say yes for all of them.
Because we put Neil also. I just
Yeah. So just
finalize
put the final teams again on this, and then we'll talk about it.
Do it right now.
Cool. So see you all next weekend, next Saturday, and anybody who has doubts can stay back.
Thank you.
Bye.
Thank you.
Bye.
Yeah, you can ask your question, Shiv or Viraj, who wanted to ask.
So we wanted to speak to sir, like we had told sir in the beginning.
Speak
to him about our. So our teams are there. That's why we didn't do it in the beginning. Because ideas.
Sorry.
No, miss, in the beginning we didn't do it because like are there
No,
and
you
we
can ask
wanted to
now.
speak up.
You can ask
So
now.
Miss is trying to say the other teams are also present here. That's why he doesn't want to tell.
Arey bapre.
Yes,
It doesn't
that's
matter,
why we.
Shiv, it doesn't matter. Because
No,
this is.
Miss, we've got a very special mechanism, Miss. That's why, Miss.
Okay.
I'm really sorry, miss. We've done like a lot of research and stuff, and we've reached out to FRC teams as well. So.
Which FRC team you reached out to?
No, there's one team called R Factor. So like when I put the our fundraising thing on my previous school's group, that one person from that team contacted me, and like that R Factor team is doing this free workshop from October 2nd to October 4th for FTC teams as part of their outreach.
Yes.
So our team attended that. And
Okay. So we'll anyway
Miss,
talk
so
about it.
since we both want to share each other's ideas, miss, so I can leave and then join back after 5 minutes. Is that okay
Okay,
with
do
you,
that.
Shriva?
Fine, fine. Do that. Fine. Okay.
Miss, can we
Miss,
stop
and
recording?
you also keep.
No, I can't stop recording. Shiv, it cannot be this private as this recording is not shared with anybody. So it's okay.
oh yes, miss. No, miss. I don't have any problem with stopping recording. That's it.
Sir
Who had
and
this
Shiv,
problem about
I'll
recording?
join back after 5 minutes, okay? Miss, is
Okay,
that
okay.
okay?
Yeah.
Thank you.
Miss, sorry. Okay, so we're using this mechanism, like you said, the roller mechanism, right? So we're using a mechanism like that, like we are calling it the pasta roller mechanism. Like the ring comes and it takes it inside. So and like, can I share my screen just for a second? So can you make me a presenter? Make me a presenter.
Can I make you? I'm not sure. I'm not part of the team, so I don't think I can make anyone a presenter.
So you can make someone a presenter.
Miss Meenal, can you make me
Yeah.
a presenter?
Actually, even I can't make you presenter because I don't have I only Vayun has it and he's not here now.
No, miss, you have to click on the person and just
I don't have the right. Sorry.
in the participant list, you have to click on the person, and then the option will come up change to presenter.
No, you need to be part of the team in order to do that.
Yeah, I'm not actually. That's what I mean. I'm a guest only. So that's why I'm saying I can't do it. I'm a presenter. So what should I do? Tell me, I'll do it. What should we do? What should I do?
Like sir shares the sketchbook, right? So like, sir, can you share that sketching thing?
How do I make other people share their screen? That's what I'm asking you.
You need to make them a presenter first, man.
Yeah.
So how do I like 1 minute? I have to make you a presenter. Well, let me see whether I can do that.
Yes, miss. But now, sir. So, sir, like I'll show the top view of our screen. So I'm requesting control, sir.
Yes. It's not allowing me to give you control.
Screen.
Okay, I gave you control. Try now.
So I'll request control again. So wait,
Hello.
So I'm not getting. Okay, so I'm not getting control for some reason. Actually, so can you draw a upside down U, a U shape upside down?
A U shape upside down like this.
Yeah.
Okay, and
Okay.
draw a smaller U upside down inside it.
Something like this.
Oh
Yeah.
yes, sir. Perfect. So on the left opening, so on the like your mouse is on the right opening. So on this left opening, yes, sir. So we'll have like a roller that will take the ring inside. Okay, and the
Okay.
openings are going to
So
be as
this is
the rings.
view. So which view is this? Is this the top view or which view is this?
This
The
is the
top
top view.
Top view. Okay. So so your ring would be something like this.
Yes, sir. So it goes inside. Okay, and can you see that point, like the middle part of the U, the upside
Yeah.
down
This
U, the
part.
middle part? No, so the inner U, the inner U.
Okay.
So
Here.
like that. Yes, sir. Exactly. So there we'll be having like a flywheel or something. a gear that will keep spinning. Now, when the ring goes up there, it'll spin the ring and it will come on the other side. Correct?
And what are these U-shaped structures? Are they guides? They are there to guide the ring.
Yes, sir. They're
Yes,
the
sir.
tubes.
So like, yes, sir. So we are trying to, instead of having like an elevating mechanism to take it up, like we can take the ring from the front side and it can go backwards, take a U-turn from that motor there, and over there we'll have a flywheel with the ultra-planetary motor going at around 6,000 RPM that will shoot it. And now if we want to hit the power shot targets, we'll have to reduce the RPM because that 6,000 is for the top target.
So let me understand it correctly. So your ring will enter from here. It will come here, and it will get placed in this position. And then this is the flywheel, and because of this, it will get shot in this direction. That's what you're trying to do, no? And it will come out here.
It won't get short, sir. It will just rotate it very slowly. And it will,
Okay. You rotate it
Vivan,
slowly, and then it comes out here. Then
Vivan, can you join in a minute? Vivan, can you join in a minute?
Okay.
Okay, sir. So it rotates it and it gets stored on the right side for a minute. Now, when the board gets into position, we will have one motor that will slightly rotate the ring again, and there'll be another flywheel on the right side. So, the suction mechanism was on the left side, sir. The roller, the yes, sir, that is on the left side. Now, on the right side, we will have a flywheel that is going to shoot the thing.
and
Using
shooting
ultra.
it in which direction?
Sir, it will be in front
This
direction.
this
Yes,
direction.
sir. Yes, sir.
So you'll have a flywheel here.
So we'll have, yes, sir. Exactly. Somewhere there,
Either
yeah.
here or it could even be on this side. Yeah, it doesn't matter. Okay, so it goes in this direction.
Yeah.
So entire sucking and shooting happens in one mechanism itself.
And
How
to
many
pick up
motors do
the,
you need? How many motors do you need here? So you'll need one motor for your roller over here.
yes,
So there's
sir.
one motor here, one motor here, and one motor here. So you're using 3 motors here.
So we are
And
going to
we'll
be
have,
buying computers.
sir, we'll also need a smaller one so that when suppose it gets stored over here, it needs to get stored before shooting, right? Because if it just enters, goes here and shoots, it's going to shoot anywhere. It needs to get into position and then shoot, right?
Correct.
So when it gets into position, like we'll have one smaller motor that will when it gets into position, it will just slightly move it towards the flywheel and the flywheel will shoot. So we need 4 motors just for the shooting and sucking process.
Okay, so what you're saying is your ring will probably come and rest somewhere here, and then there'll be another motor that will gently nudge it into this position so that
Yes,
it can
sir.
get shot out.
Yes,
Okay.
sir.
So this can be done by a servo motor. This doesn't require a lot of torque. So this you can use servo, but and
Yes.
this also you can either use a DC motor or you can use a servo depending on how you design it.
Shooting, we are thinking of using an ultra planetary motor, the one which is on the Rev Robotics side, because it's like goes up to 6,000 RPM.
Right, you can use that. So you need a high RPM motor over here, but it has to be a DC motor here. You cannot use a servo here. This motor has to be
Shiv, are
DC.
you done?
Almost, almost. Okay, sir. So that's our mechanism, sir. So you can stop sharing.
Okay, so one thing I would suggest is not to turn the ring around and bring it back here. I would suggest let it go in one direction. So that keeps it simple. There's no harm in trying this. Feel free to try this out, but this is slightly more complicated than what I think it should be. So
Yes, sir, I know.
I would prefer it is straight.
Yeah. So the reason why we did that, we obviously thought about that method, but then what happens is it will have to take the ring from back and shoot from front. So rather you take it from front and shoot from front, right?
No, that doesn't matter so much. See, your entire process, rotating the bot by half a rotation doesn't take a lot of time, so it doesn't matter so much.
Okay, so we'll experiment with that.
Yeah, definitely experiment. So don't just assume it. Definitely experiment and see what kind of result you get.
Yes, sir. Okay, sir.
Yeah, and make sure that this entire mechanism, you should be able to change the angle at which you're shooting it out. The angle with respect to the ground.
No, sir. Before that, we'll be having we are not going to be changing the angle. We are going to be changing the speed.
We'll be changing the RPM, sir, instead of this angle.
Yes, so changing the RPM is one way of doing it, but be very careful about that, because when you change the RPM, you may not get an exact RPM after you change it. Sometimes it may be more, sometimes it may be less. So there are a lot of practical factors involved there, and you may not be able to get a very precise RPM.
Okay, sir.
So
we'll
try it out and see if you're getting good accuracy. Otherwise, you'll have to start moving the angle.
Okay.
And the other way is, don't change the RPM, don't change the angle, and just keep move the bot front and back. That is another option.
Oh yeah,
Keep
that's very good. Yeah.
No, the front and back option, sir. The problem with front and back is that in autonomous period, then the shooting will become hard. In this, the autonomous period shooting will not be hard. But when you go front and back, that the programming will be a little bit hard for the autonomous period shooting then.
From a practical point of view, making it move front and back is a more precise movement than changing the speed of the motor. Because after changing the speed of the motor, you never know whether you're going to get that exact same speed or not. It may be a few RPM more or less, and that will impact the distance. Yes, you'll need to experiment a lot and figure this out. So this is all dependent on experimentation.
Yes,
I would suggest do it and try it, and then see what works best for you.
Shiv, are you all done now?
Yeah. You can stop sharing this.
Thank you, sir.
Thank you, sir.
Welcome.
Neil, can you please leave?
Yeah, sorry.
Yeah.
Yes, sir. Sir, please can you share your screen?
Okay.
Sir, so I have an extremely weird idea.
Yeah, tell me.
Sir, so can you? Yeah, yes, sir. Sir, so you like on the front side of a bot, there will be a hole. So like a proper hole in the middle of the thing at the height of the high goal. Sir, so then, sir, so like we'll.
Did you say you'll at the front of the bot you'll have a hole at the height of the high goal?
Yes, sir. Can you hear me? Okay, sir. So what I'm planning to do. So what I'm planning to do is that, sir, so I'll create a suction pull, and on top of it will be a spring. So by the pull, so the spring will also get pressed and the ring will eject. Sir,
Sorry, could you
if you
repeat that?
draw
I
it
missed the initial part.
much, that one.
Could you repeat that? I missed the initial part.
Okay, sir, so can you just draw like a rectangle on it and you draw a circle in the middle of it?
Okay, so this is a rectangle and a circle in the middle of it.
So I'll just leave and rejoin because I can't see your screen.
Okay.
Didn't say anything, Shubho. Hello.
So now for the side view of the circle.
Mm-hmm.
Can you hear me?
Yeah, I
So,
can hear
for
you.
the side view of the circle, so like just behind the circle, there will be a vacuum. So, and on top of the circle, like on
Vacuums are
its
not
top,
allowed. No, vacuums are not allowed in
what?
FTC. A vacuum-based
Okay,
mechanism is not allowed
so
in FTC.
is there any instrument by which we can create a suction pull?
It's not allowed. Suction is not allowed in FTC.
Oh, okay, sir. So that was the complete base of my idea, but it's okay. Okay, sir. Thank you, sir.
Okay, all right.
Just 2 minutes, I'll take off yours. Hello.
Yes,
Hello.
yes, Minal.
Yeah. So should we have the thing tomorrow? Is it okay with you for an hour or so?
We can do it tomorrow. Yes.
Perfect. So that was one. And secondly, what do you think about these kids are trying to hide? Is that how it's? Is that okay?
That's okay because they are very protective about their ideas, and it's okay to if they want to not to disclose. It's okay.
Okay, fine. I generally, I personally feel that there's so many things that actually go from now until like how you drive, what you do. So it's hardly a matter of I'm personally open for everything. Typically in my head, that it should all be transparent. So I always feel this. I always try to discourage this behavior, but I thought I'll take another opinion as to how it is.
So that is how I used to think earlier as well. But then the problem that happens is then all the designs they end up looking very similar to each other because they start
Okay.
copying each other's good idea, and that is something that is not good. So
I also would want to
do it
take
separate.
in. Yeah, I can understand. I also wanted to take inputs from you on, how like now this school has 4 FTC teams, and I feel that whole competition shouldn't kill these people. So I just want to put in this whole gracious professionalism and competition in the head so that they understand what it means. Otherwise, there'll be so much of infighting. Like you saw how you go, you don't do this, you don't do that, and all. So how do you handle multiple teams from a school?
You'll need to make some ground rules, and
Yeah.
one of the ground rules that I have made is that you're not supposed to copy each other's designs. And
Okay.
any design that a team comes up with, you discuss with the mentor so that the mentor comes to know, so the mentor knows which team came up with the design first, and then that team is allowed to use that design. So that is the ground rule that I use, and I make them follow that. Many times you have to relax those rules as well because there might be a design which is beneficial to everyone, and it might be a very common design that a lot of people a lot of teams are using. Then you just allow everyone to use that. So
yeah,
you have to strike a balance between that.
Perfect. So, I mean, I too feel it's going to be very challenging, and I'm just wondering how it's going to pan out ultimately. So I keep asking you these questions because it's going to be very, very, and these are extremely competitive kids that I figured, not like somebody like me again who's okay and like.
Yeah,
we
some
cross
kids will
that
definitely
bridge.
be very competitive. Some kids will definitely be very competitive, and
Mhm,
it'll become
mhm.
hard to control them also. I face this problem every year.
The other thing was, what some parents from Pune reached out to start an FRC team. What's your view? Pune mein banega kya?
Depends if they have the funds and if they have mentors and if they have everything, then yes, why not?
Okay, so you feel that I mean, because I was just wondering what to do basically in terms of what, whether to encourage it or just tell them to keep doing this thing. What is it? To keep doing FTC only. This kid has done FTC in the past,
Mm-hmm.
and he now wants to move to FRC. Basically.
Okay, but FRC will need a bigger team and more committed students.
Yeah, that's
FTC,
what, and I don't know the Pune thing at all.
In FTC, 5-6 student team can survive, but in FRC you need a lot more people and more commitment from them.
Mm-hmm. Okay, so maybe I'll just kind of again ask whether what is happening. So the school, I do not know much. That school principal is going to talk to me.
Okay.
But just
So
trying to figure out.
my son is also behind me to start an FRC team because he has done FTC for many years and now he wants to move on
So
to
करो
FRC.
ना सुमेश, then हम लोग मतलब I'll get you these 4-5 kids and start ना. I'm there to be the back. Well, I mean whatever help that you require on it. And this is the
Actually,
best
that's
way
not a
with
bad
the.
idea. Think about it.
Yeah, because this is also good. You know why? Because it's all very virtual and all that stuff. So it's a good. And the parents who I'm in touch with are very good parents, so they will also back up very well.
Okay, and which school is this? Do you know
Some
the name of it?
DLRC school.
Okay.
Do you know?
No,
Do you
no,
know?
I haven't. No, I haven't heard of them.
But these parents are very, very, very well connected. I mean, it's that lady from my IM group only. So she reached out saying that, you know, if you do this, then why don't you also do it for my children and all that. So I thought I'll kind of reach out and figure out with you whether, you know, what's your view.
Right. I think we should say in India, we have very few FRC teams. So if there is a team that is willing to get built up, I think we should encourage that.
That's what I'm saying. So which is why already I'm actually this year I'm entering 5 FRC teams, just so you know. So it's
5?
anyway,
Nice.
yeah, suddenly they became 5 from nothing. You know, I'm like, oh God, what happened? But they are doing well because as long as, so in each of these schools, there are people from who are willing to take it up, like how you are there, for example. So similarly, there's an anchor, and everywhere you require an anchor because otherwise it's very difficult to do it, right?
Right.
So everywhere there's an anchor who is going to be responsible. Like in your case also, I mean, so basically I kind of, you know, just get the whole system in place and do the whole basic skill building in CAD and programming, because that's what's required. But the second part, which is and the map the outreach calendar, because it's so important in FRC, especially this year, because they are looking at just doing FRC only. In the sense that they're looking at a lot of outreach being a mainstay for this actually.
Okay. Mm-hmm.
So I have around 4 kids interested from Pune. And so then you let me, I mean, basically this will require 10-15, but this year the costs are also low. Everything is only low. You know, it's, I mean, I think it's as how much of money will go in FTC, thoda sa upar, the delta will be very little.
I hope so. Yeah.
So in case you're thinking, they go through the thing. I'll share the FRC document with you, so you can look it up. And then if you feel, then you let me know. Then I'll connect, and then we can have at least an initial meeting to see whether it's kind of going anywhere.
Sure. I'll get back to you on this.
Perfect. Okay. And then tomorrow we can have the other call, basically.
Yes. What time are we having it? Around 3?
So, what time? 3 is good for you?
Is it possible to do a little earlier?
Yeah, what time?
Maybe 1 o'clock.
1 would be bang in the middle of lunch hour, and this will be like an hour at least. So 1 to 2 thod ke 2 is fine. Yeah.
Okay, let's do
What
it.
time do you get done with lunch?
My lunch time is not fixed. So sometimes I have it at 4, sometimes I have it
Oh my
early.
God.
It's not fixed at all. Yeah.
Oh God.
No, for me, it's not a problem. So if 2 works for all of you, let's do it at 2.
Perfect. Okay.
Okay, all right. Thanks,
Yeah,
Manoj.
thanks. Bye. Bye.
Bye.